Hello again. It's Tuesday, time for your last video before we're together, at least on Zoom on Wednesday. I'd like to show you that today you're moving into the third and final packet of organic chemistry. You're going to be opening up the packet that's all clipped together for instruments. It's called topic 11.3, spectroscopic identification of organic compounds. This is what the class packet looks like. It is your third class packet. I will be making reference to the class packet in today's video. There is also this pale yellow set of practice problems. This tells you where we're going to be able to go at the end of about 5 days working on these spectra. I will be giving you 3 different types of spectra. Each of those, the mass spec, the infrared, and the HNMR, tell you a different clue about an unknown organic compound. We put those clues together and you tell me, Mrs. Suggs, that is 3-pentanol. And you'll be able to tell me what organic compound it is from reading these graphs. It's really a lot of fun. Also in the packet of materials with instruments besides your class notes and this pale yellow practice is a bright yellow card that has 2 charts on it out of the IB data booklet that you'll need for resources. 3 charts actually. Then I'm going to be going over a PowerPoint with you, and the PowerPoint will help you understand this topic. I have printed up specific slides in the PowerPoint. I call them the yellow slides. Every time I'm going through my PowerPoint and you see a yellow slide, it is in this handout for you so that you'll be able to take notes in this handout to better understand this topic of 11.3. So I will begin going over the PowerPoint and I'll go back and forth between the yellow slides, which are here for you, and I'll make a quick reference also to your class packet. Topic 11.3, modern analytical chemistry. This is on the PowerPoint. The PowerPoint's posted in Schoology. Remember, every time you see a yellow slide, it is copied for you to take notes on in this packet. You are going to learn to identify organic compounds by being given a series of clues. The first clue that I'll teach you today is how to determine the index of hydrogen deficiency from having been given the molecular formula or the structural formula. And then it'll take me the rest of a week to show you how to interpret mass spectroscopy, HNMR, and infrared spectroscopy. This is on the cover of your class packet. I'll point out more of this information to you, but this section is about analytical chemistry. Analytical always means instruments. For me, it was a chemistry course that I took my junior year at Purdue. It's a more advanced chemistry course. We'll look at this and talk about it more together. In these class notes, oh, sorry, I wasn't sharing it with you. So here is the first slide that I was talking about, being able to understand how to get the index of hydrogen deficiency and the 3 instruments that I'll teach you. Then this is the cover of your class packet that I'll talk to you more about when we're together. Plan to read in these class notes, your class packet, pages 2 and 3. It has good background material. I'll talk to you about mass spec when we're together on Wednesday. But now, if you would jump to page 7 and 8 in your class notes, I'll proceed with that information. So you are going to learn how to determine the degree of unsaturation. That's what it's called, the degree of unsaturation, or the index of hydrogen deficiency. You're going to see both of those terms, and I wish I could keep it easier for you, but both terms will need to be used for this particular topic. Here I have 3 different molecules. A ring of 6 carbons, which is not benzene because it doesn't have the circle in the middle. This double bonded ethene and a triple bonded ethyne. The point of learning how to determine the index of hydrogen deficiency is to learn more about the molecule. If you know how many hydrogen molecules have to be added to make a saturated compound, it tells you something about the structure. It will tell you if there are rings or double or triple bonds. So how many molecules of H2 would be needed in theory to convert each of these 3 molecules into a saturated non-cyclical molecule? So here I have C6H12, here I have C2H4, and here I have C2H2. Here are the molecular formulas for those same 3 compounds. I would ask you again, how many H2 molecules in theory would be needed to convert those into saturated non-cyclic molecules? You're going to learn how to determine this index of hydrogen deficiency, both from being given the formula, and you'll be able to determine the index of hydrogen deficiency by being given the structure of these molecules. The method I'm going to use to show you how to determine the index of hydrogen deficiency first starts with looking at the molecular formula. I'm going to give you some tricks to take the provided molecular formula and manipulate it. Notice that I called these red formulas the manipulated formulas. There are some rules you're going to have to learn to turn the given molecular formula into the manipulated formula. Then that is much easier to look at to determine how many hydrogen molecules you need to add to make a saturated compound. So when you're given the molecular formula, I rewrite the formula, manipulate it to make it into a saturated non-cyclic molecule. If I've got 6 carbons, I know I need 2n plus 2 or 14 hydrogens to saturate it. If I'm given 2 carbons with this second formula, I know I need 2n plus 2 or 6 hydrogens to saturate it. If I'm given C2H2, 2 carbons, I need to get it to C2H6 to have it be a saturated compound. Now, when I compare the given formula to the manipulated formula, how many hydrogen molecules did you have to add to accomplish that change? To go from 12 to 14 hydrogen atoms, I needed 1 molecule. To go from 4 to 6 hydrogen atoms, I needed 1 H2 molecule. And here in the third example, I needed 2 molecules. So here are the rules. When you see a double bond, I know I have to add 1 hydrogen molecule to break that double bond. A triple bond would require 2 hydrogen molecules to fully saturate the triple bond. A ring requires 1 H2 molecule to break and saturate. An aromatic requires 4 hydrogens. You can think about that just a bit. So the IHD can be worked out 2 ways. First, I'll show you the structure, and you'll determine how many hydrogen molecules are required to saturate. Secondly, I'll give you the molecular formula, and you'll still determine how many hydrogen molecules are necessary, the index of hydrogen deficiency. If you would go to page 7 of your class notes. This handout is showing you both of those methods. Here, I'm giving you the structure of these compounds and the names, and I've given you the index of hydrogen deficiency. When I see a saturated compound, I see no double or triple bonds. I see no rings. There's no hydrogen I add to make a saturated compound. When I'm looking at butene, I see a double bond. One double bond requires one hydrogen molecule to saturate. When I'm given butane and I see it as the structural formula, that triple bond requires two hydrogen molecules to saturate. When I see a ring, think of the ring needing one hydrogen molecule to break. That's always going to be true. Now, the other way you need to do this is sometimes I give you the structure this way. If you have a benzene ring, you know that you have both a ring to break and the equivalent of 3 double bonds. That gives you an IHD of 4. Cyclohexane is 1 ring to break. Cyclopentadiene is a ring to break and 2 double bonds. Acetaminophen, you would have to look closely at this molecule and add up both the breaking of an aromatic ring and any other double or triple bonds in the molecule. So, how many hydrogen molecules have to be added to saturate these molecules? Here you have a double bond. That would require one hydrogen molecule to saturate. Here you have a ring. That would require one hydrogen molecule to saturate. Here you have 2 double bonds. That would require 2 hydrogen molecules to saturate. Oh, and down here, here you have a ring, 1 hydrogen molecule. Here you have another ring, 1 hydrogen molecule. But if you have a benzene ring, it's really the equivalent of a ring and 3 double bonds. So the IHD for benzene is 4. So here are the rules, and I'd like you to study them and carefully learn them from this yellow slide. If the compound only contains C and H, then compare the formula, the given formula to the formula for a saturated hydrocarbon. Determine the number of hydrogen molecules that must be added to saturate. If the compound contains an oxygen, ignore the oxygen and go on determining how many hydrogen molecules have to be added. If the compound contains a halogen, you have to add 1 more hydrogen onto your formula. Take the halogen off. If your compound has a nitrogen, you have to subtract 1 hydrogen from your given formula and then figure out how many molecules of hydrogen to add to saturate. So you're going to compare your given molecular formula with these resulting manipulated formulas and determine the IHD. Here are the rules simplified for you, another yellow slide, so you have this information in front of you. 5 simplified rules. If the given formula only has C's and H's, just do it. Just look at how many double or triple bonds or rings you have to break to determine saturation. If there's an oxygen in the given molecular formula, ignore it. If there's a halogen, manipulate your given molecular formula to add 1 hydrogen. I think like halogen, higher, add 1 more. That's a clue. Halogen, add 1 more, higher number of hydrogens. If there's a nitrogen, subtract 1. I think of the word niet, no, take it away. Then compare this manipulated molecular formula to what it takes to saturate the compound. So here I have an example of what I mean. Page 8 of your instruments class packet. If you are given C6H6 as the given molecular formula, just write The saturated formula, you know that with 6 carbons, you need 14 hydrogens to saturate and make an alkane. Compare 6 hydrogens to 14, you would have needed to have added 4 molecules. I didn't need to manipulate the formula because there was no O, no halogen, no nitrogen. Here's a formula. The given formula has an oxygen. So I'm going to manipulate it and just drop out the oxygen. This is not the real formula, but it helps me determine the IHD. Now, from this manipulated formula in the second example, I then write the saturated formula. How many hydrogens go from the manipulated to the saturated? 1 molecule. Here I have 2 oxygens in the given molecule. Forget about them and write down your manipulated formula. Write the formula in its saturated form. How many hydrogens would that take to accomplish? With the chlorine, you add 1 hydrogen in the manipulated formula. Instead of C2H3, make it C2H4 in the manipulated formula. How many H2s to saturate? 1. Nitrogen, in your given molecule, if you have a nitrogen, take it off, manipulate the formula by losing 1 H, niet, losing 1 H, and then calculate how many hydrogen molecules it takes to saturate. Now, from these formulas, you should be able to, here's the given formula, write the manipulated formula, then rewrite it so that it's saturated. You know saturated is C to the N, H to the 2N plus 2. Then compare the manipulated and the saturated to determine how many hydrogen molecules were needed to accomplish that. Now you can do this from looking at the formulas, or you can do this by looking at the structures here. Look at this third molecule. I see a double bond, a triple bond, and a double bond. That should tell you how many hydrogen molecules you need. Look at this middle structure. I see a ring to break, 2 double bonds, and another double bond coming off the ring. That should tell you how many hydrogen molecules you need. For this first molecule, you have a benzene ring and a triple bond. It all makes sense if you keep working on this. So I have these answers on the next page for you. If you haven't done these, go back and try to figure them out. And here are the answers. I will do more of these with you so that you can look at the structure or look at the molecular formula and determine one way or the other what the index of hydrogen deficiency is. Or remember, you can call it the degree of unsaturation. Here is a chart on a yellow slide that you can do. Here's the given molecular formula. You manipulate it according to whether you have an oxygen, a halogen, a nitrogen. Manipulate the formula. Then write the formula having saturated it. Tell me the IHD. If you haven't done it, first do it and then look at your answers. There is an exercise in your book that you can do with my sample problems, the answers provided to you. So this is not so hard. You just have to learn the rules, appreciate what we're trying to do, and know the reason IB is asking you to determine the index of hydrogen deficiency is so when we get into our problem solving of what is this organic molecule, you have one more clue as to the original structure of that unknown molecule. Thank you for your time. This is the Tuesday video. I will see you on Zoom on Wednesday. Thank you.